So now we realize that we can use either the TI-84 or StatCrunch to be able to solve all sorts of binomial probabilities for us with no tree diagrams, no rules involved, just basics. And it's all written out for us in this table right here. Now this was written for the TI-84. So when you look at this table, it's the TI-84 functions. StatCrunch is actually a little bit more intuitive. So StatCrunch, you'd actually want to look at the symbols because remember you have those options when you're in StatCrunch. So you might want to make a note that the symbols are more important for StatCrunch. And these are more for the TI-84. And again, this particular table doesn't have to be memorized or anything. It's right on the exam notes packet, right? It's right there. So you don't have to memorize it. This is the exam notes packet in the appendix, and there it is. All right, so let's put it into use with our example. Again, we're going to keep going with the student that, suffers through this 10-question quiz that they have no idea what's going on. Okay, so remember, again, one more time, n is 10, and each question had 5 options, only one of which is correct, so p is 1/5, which is 0.2. Okay, first thing they want us to do is describe p of 4 in words and find its value. I can't tell you the number of times that I ask this question and students don't write the words part, which is actually pretty easy. So all I'm asking you is, what does that mean in the context of the situation? So p of 4 means the probability the student guesses 4 questions correctly. Simple as that. Now let's find p of 4. All right, so now notice it's giving you a number. See? So look at part 1 right here. Given number. If you're given a number, a specific number like that, then you're using binompdf on the calculator or the equal sign in StatCrunch. Okay, so we're going to find p of 4 by, and write either one, right? It doesn't really matter. So I'll write the binompdf portion just for our own benefit, but we can make it work in StatCrunch as well. So to be 10, it'd be 1/5, and we're looking specifically for 4. And we want to know the probability that x, this is essentially the same thing as probability of x equals 4, right? So when you're given a number like that, that means this. Okay, so if I go to the calculator, let me grab a calculator first. I'll just go grab it again one more time. So second distribution, go to binompdf just to show you one more time how to do it. 10, enter, 1/5, enter, 4, enter. When I take it in, it pastes it in, and then I have to press enter to run it. And I get 0.088. All right, so be it. 0.0881 if we round. All right, now if I grab StatCrunch instead, it's just as easy. So I'll show you one more time. So you go to Stat, Calculators, Binomial, click on the binomial. You want to tell it 10, 1/5 or 0.2. I want to choose an equal sign and say 4, enter. And there you have it, 0.000881. Same as it was with the calculator. All right, now what about the probability that x is less than 6? Well, that would mean the probability that the student guesses, I'll switch colors, probability x less than 6 means the probability the student guesses less than 6 is correct. That's not less than or equal to, that's less than. So less than 6 questions correctly. Okay, so probably x less than 6, you follow the table. If you're going to use the calculator, if you're going to use StatCrunch, you have to use well, StatCrunch is a little bit easier, so I'll show you that in a minute. But less than is right there in the second line. So you see where it says npx minus 1. The x that was given to us is 6. So you're going to use binomcdf 10 1/5, and you're going to use 6 take away 1. Now, if you like, you can write 5, or you can write 6 take away 1. The calculator will handle it either way. So let me show it to you. So second distribution, binomcdf. Be super careful, by the way. Sometimes students accidentally pick binompdf when they mean CDF and vice versa. So just be extra careful. It shows you at the top of the screen that it's using binomcdf, which is a sign. StatCrunch is a little easier because it shows you all the bars that are lit up. So if it lights up more than 1 bars, that's a sign that you're adding more than 1. All right, so 6 minus 1. I can literally just type 6 minus 1. I don't even have to type 5. And it knows that it's 0.9936. So chances are the student is going to get less than 6 correct. That is just the way this is going to work. Now, StatCrunch is, I think, even simpler. When you're in here, we already have the 10 and the 1/5. You just switch to a less than and make it 6. It looks like it looks on the page. Simple as that. So I want x less than 6. It finds it for me, 0.9936. No fussing around with x minus 1s or any of that stuff. It just takes care of it for me. And you can see it's adding 0, 1, 2, 3, 4, and 5. It's stopping at 5 because we want less than. All right, now time for the next one. And this one's actually the trickiest one of all of them. It's not specifically in this because it's a little bit tougher to do. So this is the probability. It means the probability that the student guesses between 3 and 8 correct. And on the calculator, this is not going to be easy. I'm actually going to do it in StatCrunch first because StatCrunch is easier. Student guesses between 3 and 8 questions correctly. And I'm going to say inclusive. What that means is 3 and 8 are included, right? Between 3 and 8 implies 4, 5, 6, and 7. So I want between 3 and 8, including 3 and 8. That's why there's those less than or equal to signs. That's what that word means. Might want to make a note of that, right? So inclusive, but means equal to right there. Okay, so let's use StatCrunch. StatCrunch is actually way easier on this problem. Okay, so in StatCrunch, when you're in the binomial calculator, you can actually click on the between, and it'll let you do between. And it has automatically less than or equal to. So I can just say 10, 1/5, 3, and 8. Enter. And there you have it. It's adding up 3, 4, 5, 6, 7, and 8. You can't see 7 and 8 because they're so small it doesn't even bother graphing them, but they're there. And we get 0.3222. Seems easy enough, right? Now, how do we do this on the calculator? Well, the problem is the calculator always adds from 0 all the way up. So what you do is you take a binomcdf for the top number. This is going to be harder. Again, StatCrunch, you can make a note. StatCrunch is easy for this problem. And feel free to use it if your instructor allows you to, which they should. All right, but if you want to know how to do it in the calculator, what you do is take the probability that x is less than or equal to 8, and you subtract away the probability that x is less than or equal to 2. 2. That was not a typo. Here, let me make it 3 minus 1. That'll make it really clear. Or let me put it this way. How about this? This will be better for you. Less than 3. Less than. I mean it. What's happening is, if you look back at the StatCrunch graph, it becomes obvious. You want 3, 4, 5, 6, 7, and 8 to be added up. So you want less than 3, which is 0, 1, and 2 to be added, and then take it away from 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to add all the way from 0 to 8 for the first one. So this one would be I'll have to write it over here, binomcdf 10, 1/5, 8. That starts at 0 and adds all the way up to 8. And then I want to subtract away binomcdf 10 1/5 2. It's 3 take away 1, if you will. Here, let me write it that way. I don't want it to be 3 because then I would be subtracting off the 3, and I want 3 to be included. There's an or equal to on 3. So if you like, you could write this one as x is less than or equal to 2, whichever way makes you happy, right? One way or the other. And that's why this is 2 right here. And you're going to get the same answer. I mean, we already have it. We have it sitting there with StatCrunch. It's 0.3222. But let me prove it to you. So if I go to the calculator, I'm going to clear all this out. So second distribution, binompdf. Yes, I could have grabbed it from earlier, but that's okay. 10 1/5 8. Paste. This is why we're pasting, right? Because if I paste, then I don't have to run it. I can actually just write minus and then go grab another binomcdf, or binomcdf, excuse me. So binomcdf 10 1/5 3 take away 1. Paste. So it did the first binomcdf minus the second binomcdf, and I have to press enter to run it. And there it is, 0.3222. The same answer we got out of StatCrunch with a lot less agony. So there you have it. So this is 0.3222. I don't actually care what either one of the probabilities is. What I care is that I can find the probability between. And StatCrunch is way easier on this problem. All right, last but not least, to pass the test. Passing. Passing is good. So the student wants to pass the test. They have to get 70% or more correct. Well, how many questions would that be? And then would it be unusual to pass? Okay, so if they want to pass, let's figure out what that is. They want to be 70% or more. What's 70%, which is 0.70? Let me do it this way. 0.70 times, there were 10 questions, which is 7 questions correct. So if they're going to pass, they need 7 questions or more correct. I could spell passing. There we go. So passing would be 7 questions or more. That's just a little bit of logic, right? Okay, so then would it be unusual to pass? Well, unusual, this little word right here means less than 5%. And I think the answer is going to be yes, but let's prove it. So is it unusual? We need the probability to be able to compare. So I need the probability of passing, which is the probability of 7 or more correct, which is the probability that x is greater than or equal to 7. Greater than or equal to, all right, let's go back up and look. Greater than or equal to is right here. So we'll type 1 minus binomcdf n, which was 10, p, which was 1/5, and x minus 1. I mean, it has it right there in the formula, x minus 1. So we type 7 take away 1. Okay, so let's type that right into the calculator. 1 minus binomcdf. So second distribution, get to binomcdf, there it is. So 10 1/5, 7 take away 1, which is 6. You could write 6 if you wanted. And this is why it uses a paste feature. It's so that you can enter it into an equation like this. So if I press enter, it actually has figured everything out for me. Ooh, that's interesting. So what you don't want to tell me as the instructor is that the answer is 8.644, because that shows you didn't learn anything from chapter 5. Remember, probabilities can never be higher than 1. But it isn't. Look carefully. There's an E negative 4 after it. What that means is the decimal is 4 spots over to the left. So if I write 8.644 right here, you move that decimal 1, 2, 3, 4 spots, and it goes right here. And there's your probability. Now, I'm okay if you write it like this. That's fine. I know what that means, but you want to make sure you have that E negative 4 there, Or you could write 0.0008644. That's also correct. And I was just showing how to do that work down there. And again, I think this is easier on StatCrunch. I think binomial just in general is easier in StatCrunch. So here I am in this binomial calculator, and I don't want to do between, which is currently the light one. See how it's white? So that's what we're doing right now is between. You can see it down here. So if I click standard, the blue one, now I'm on standard. So it's kind of weird. The blue one's the thing you're not doing. It's kind of strange. So I want to be 10 and 1/5, but I want to be greater than or equal to, so I choose greater than or equal to 7. Enter. And there you have it, 0.000864, just like that. And you can see none of these are red because what's happening is it's adding 7, 8, 9, 10, 11, or excuse me, 7, 8, 9, 10. We don't get to see those because they're so small that they're not worth graphing for the computer program. But they're over here on the right, 7 right here. If I did less than or equal to 7, you'd see them all turn red. See, there's less than or equal to 7. So if I do greater than or equal to 7, technically this little red one, this little 7 over here should be red, but it's too tiny to graph. And you'll notice, in my opinion, that's a lot simpler than the whole binomcdf 1 minus thing. So remember, when you're looking at this table, these are the rules for the TI-84, and StatCrunch is a little bit more intuitive. You just pick the correct symbol that's matching what you want, and away you go.